Right now, you are breathing in atoms that were forged in the violent, catastrophic deaths of ancient stars. The very oxygen filling your lungs and keeping you alive does not belong to you. It is the scattered debris of a cosmic explosion that happened in the deepest, darkest corners of space. We always believed we understood exactly how and when those essential elements were made. We thought it took a slow, agonizingly long time for the universe to build them. But we were wrong. We have just found those exact same elements existing near the very dawn of creation, long before they had any right to be there, hiding a terrifying secret about our origins. For decades, the textbooks painted a very neat and comforting picture of our cosmic origins. We were taught that the universe began as a tiny, infinitely hot point that simply expanded outwards into a quiet, empty void, slowly cooling down to form stars and galaxies over billions of years in a peaceful, orderly fashion. It was a story of a silent dawn, followed by a steady, calm evolution where everything took its proper time to grow. But the latest data pulled from the absolute edge of space has completely shattered that old familiar narrative. Today you'll find out what the early universe really is, and why its impossible galaxies might be the glowing embers of a completely different universe that existed before our time began. Before we set off, one question for you. Where in the world are you watching the sky from, and what time is it where you are? If you love wandering through the night sky, subscribe to the channel. That's what keeps this work going. Let's plunge into the cosmic dawn. To understand what this impossible discovery means for us today, we first have to look at how we mapped the cosmic timeline in the first place. For a long time, the history of the cosmos was just a rough sketch. Ever since Edwin Hubble proved in 1929 that the universe was expanding, you knew that the past must have been hotter and denser. But the exact details of its infancy remained completely hidden behind an impenetrable wall of time and distance. We needed a perfect map. We needed to see it. In 2009, the European Space Agency launched a marvel of engineering called the Planck satellite. Its mission was to stare deep into the cosmic microwave background. Planck was equipped with a sophisticated physical setup relying on sensitive bolometers. These detectors absorbed the faint heat of ancient microwave photons, measuring temperature fluctuations down to 100,000th of a degree. Because the universe is freezing, these instruments had to be cooled down to just 0.1 degrees above absolute zero. This engineering triumph allowed us to see the microscopic pores on the baby skin of the universe. It captured the quantum fluctuations that would eventually grow into everything you see today. The data from this satellite was so incredibly precise that it allowed cosmologists to calculate the exact rate at which the universe is expanding today, a number known as the Hubble constant. The Planck team looked at the echo of the Big Bang and predicted that space should be stretching at a speed of 67 kilometers per second per megaparsec. It was a definitive mathematical certainty derived from the oldest light in existence. But when NASA used the Hubble Space Telescope to measure the expansion rate using nearby Cepheid variable stars, they got a completely different number, 73. This discrepancy, known as the Hubble Tension, was the very first crack in the pristine glass of modern cosmology. It hinted that perhaps early dark energy or some unknown physics had tampered with the expansion rate while no one was looking. By the time the Planck Consortium released its definitive maps, a deep sense of absolute victory settled over the scientific community. The standard model of cosmology was officially crowned as the ultimate truth. Everything was solved. The story was complete. The universe was exactly 13.8 billion years old. The recipe was perfectly understood. The entire scientific establishment was confident that the broad strokes of cosmic history were permanently etched in stone, or, according to this flawless model, the period immediately following the Big Bang was known as the Dark Ages. This was a dark, featureless, and incredibly quiet epoch. There were no stars. There were no galaxies. There was no light. It was an absolute void filled only with a thick fog of neutral hydrogen gas, slowly expanding and cooling. The textbooks were rewritten with a rigid, unbreakable timeline. We were told that building a galaxy was a painstakingly slow, agonizing process. You cannot just throw gas together and expect a sprawling, majestic spiral to appear overnight. It requires hundreds of millions of years for gravity to pull cold gas into small, clumpy, chaotic dwarf galaxies. These tiny structures then have to slowly crash into each other, merge and stabilize over billions of years. If you look back at the first few 100 million years of the universe, you should only find small, fragile structures. The universe was supposed to be a slow, sleepy engine that took a very long time to warm up. To make matters even more complicated, the standard model included a massive hurdle known as cosmic reionization. When the universe first cooled down, protons and electrons combined to form a thick, opaque mist. Light could not travel freely. For the cosmos to become transparent, the very first stars had to slowly ignite. They had to emit enough ultraviolet radiation to hit those hydrogen atoms and knock their electrons away. This process was supposed to be a grueling billion-year battle. The light had to literally punch holes through the darkness, slowly merging these clear bubbles until the entire cosmos was visible. It was a mechanical process that simply demanded a vast amount of time. You cannot rush reionization, or so we believed. And then the moment of truth arrives. We launch the James Webb Space Telescope. The telescope unfolds its golden mirrors in the freezing dark of space. The data starts to flow back to Earth. Astronomers point this mechanical eye at a tiny, seemingly empty patch of the sky. They fully expect to see the faint, fragile little clumps of gas predicted by the standard model. They anticipate a quiet, dark, early universe. And in that moment, the impossible happens. The numbers flash across the screens. The timeline completely falls apart. Between 2022 and 2023, Ivo Laber and his team at Swinburne University of Technology analyze this incoming data. They look at the era just 500 million years after the Big Bang. Instead of finding tiny building block dwarf galaxies, they find monsters. They discover 6 incredibly massive, fully mature galaxies bursting with hundreds of billions of solar masses of stars. These structures are as massive as our own Milky Way, but they exist when the universe is barely out of its infancy. The researchers immediately dub them the universe breakers. These universe breakers are a glaring, screaming violation of everything you were ever taught. Imagine you're watching a construction site where workers are building a massive skyscraper. If you look away for just 5 minutes and turn back to see the building completely finished, your mind would reject what your eyes are seeing. The physical limits of the crane simply do not allow for a skyscraper to be built in 5 minutes. That is exactly what Ivo Laber and his team are looking at in the deep cosmos. These galaxies have simply grown too big, too fast. According to the standard model, there simply has not been enough time for gravity to pull that much matter together. The quiet, sleepy early universe is actually a violent, chaotic, and incredibly efficient star factory. To understand how they know exactly when these galaxies existed, you have to look at a concept called redshift. Redshift is the stretching of light caused by the expansion of space itself. As a photon travels through the expanding universe for billions of years, its wavelength is stretched out toward the red end of the spectrum. The higher the redshift number, the further back in time you're looking. When the Swinburne team calculates the redshift of these universe breakers, the numbers are undeniably high. The light places these massive galaxies squarely in an era where they have no right to exist. The sense of triumph that accompanied the Planck satellite maps is now replaced by total confusion. The perfect timeline is shattered. The standard model is broken. If galaxies can form this fast, then your entire understanding of cosmic evolution is fundamentally flawed. Cosmologists scramble to explain this anomaly. Perhaps the dark matter clumped together much faster than we ever calculated. So, Or perhaps the universe you are living in is not the simple linear story we have been telling ourselves. We finally built the ultimate time machine to confirm our perfect theories, and instead, it showed us a universe that refuses to obey our laws. The universe breakers proved that the cosmic dawn was a chaotic, violent, and impossibly rapid explosion of mature structures. We thought we had reached the absolute limit of the mystery. But the confirmation of these ancient giants raised an even more troubling puzzle. But this puzzle isn't just about finding a few massive galaxies, it's about tearing down the entire foundation of time itself. To grasp why the cosmological community is currently in a state of absolute panic, you have to look past the James Webb data for a moment. We need to rewind the clock back to the year 2010, when a brilliant mathematician dared to challenge the ultimate taboo of modern physics. Roger Penrose, a towering figure at Oxford University, proposed an idea so radical that it made his colleagues profoundly uncomfortable. For decades, everyone had accepted that the Big Bang was the absolute impenetrable beginning of everything. There was no before, because space and time themselves were created in that singular instant. But Penrose argued that this was a mathematical illusion. He introduced a theory known as conformal cyclic cosmology, or CCC for short. According to this model, our universe is not a unique one-time event. Instead, it is just one chapter in an endless, eternal book. Penrose suggested that the universe goes through infinite cycles of birth, expansion, and death, which he called eons. When Penrose first published these claims, the pushback from the scientific establishment was swift and brutal. This was a massive clash of opposing views. Several independent cosmology teams ran their own statistical analyses on the cosmic microwave background. They published papers declaring that Penrose was simply seeing patterns in random noise. They argued that the human brain is wired to find shapes in the clouds, and that the anomalies Penrose was pointing to were nothing more than statistical ghosts. The scientific community is notoriously harsh when it comes to theories that challenge the established order. Prominent physicists wrote blistering rebuttals stating that the universe is chaotic, and that random temperature fluctuations in the cosmic microwave background could easily mimic the circular patterns Penrose was predicting. It was a classic academic standoff. On one side, you had the elegant, sweeping mathematics of a genius who had spent his life studying the geometry of space. On the other side, you had the rigid conservative consensus of a community that demanded physical, undeniable proof before rewriting the textbooks. For years, this brilliant theory was marginalized, dismissed as an elegant but entirely unprovable piece of theoretical speculation. The community was not ready to let go of the comforting certainty of a single, clean beginning. But Penrose's theory was not just based on beautiful mathematics, it was rooted in the groundbreaking work of his close colleague Stephen Hawking. Back in 1974 at Cambridge University, Hawking had made a shattering discovery about black holes. He proved that they are not completely black. Over unimaginable stretches of time, black holes slowly leak radiation, a process now known as Hawking radiation. Eventually, they evaporate and explode. Penrose realized that at the very end of an eon, when the universe is utterly cold and empty, all the matter is eventually swallowed by supermassive black holes. And when those black holes finally evaporate, they release colossal bursts of energy. Penrose predicted that this energy would leave a permanent scar on the next universe. He called these scars Hawking points. It is fascinating to realize that the philosophical roots of this cyclical time concept do not originate entirely in modern European institutions. Long before particle accelerators or space telescopes, the idea of an endlessly cycling cosmos was deeply embedded in human thought. If you look at the works of 11th century Islamic scholars like al-Biruni, you will find extensive discussions on the cyclical nature of time and creation. Similarly, ancient Indian philosophical texts have for millennia described a universe that breathes in and out, undergoing endless cycles of birth and destruction. For centuries, Western science dismissed these ideas as pure mysticism, favouring the linear, strict timeline of the Big Bang. But here was Roger Penrose, bringing the intuition of ancient philosophers directly into the rigorous, unforgiving realm of mathematical physics. For over a decade, the debate over Hawking points remained a niche, unresolved argument. But then, the James Webb Space Telescope opened its eyes, and the theoretical suddenly became violently physical. Fast forward to the year 2026. A team of researchers led by Vadim Rusakov and Albert Sneppen at the University of Copenhagen begins analysing a new set of the James Webb Space Telescope data. They are looking at a phenomenon they call little red dots. To capture these impossible objects, the James Webb Space Telescope relies on its near-infrared camera, or NIRCam. This is not a simple magnifying glass. NIRCam is a physical marvel that uses specialized filters and incredibly sensitive mercury-cadmium telluride detectors. When a photon travels for 13 billion years, its energy is stretched so far into the infrared that it becomes completely invisible to human eyes. The telescope's massive gold-coated beryllium mirrors act as a giant bucket, collecting these exhausted ancient photons one by one. The detectors must be chilled to -233 degrees Celsius just to prevent the telescope's own heat from blinding its vision. This extreme physical setup allows astronomers to pierce through the thick cosmic dust and see the true colors of the early universe. And what they saw through these frozen detectors completely defied explanation. These are not just normal galaxies. They are extremely compact, incredibly luminous objects that seem to be powered by supermassive black holes. But there is a massive physical problem with these little red dots. They are simply too dense, and their central black holes are too gargantuan for their age. Just like the universe breakers discovered by Ivo Laber, these structures fundamentally violate the speed limit of cosmic evolution. The crisis spirals rapidly out of control. If you try to build a supermassive black hole from scratch in the early universe, you run into insurmountable physical barriers. The gas heats up, pushes back against gravity, and stops the black hole from feeding. It is a suffocating bottleneck that prevents rapid growth. Yet the data from Copenhagen is undeniable. The little red dots are there, staring back at us with impossible mass. This is where the discarded theories of the past suddenly roar back to life. If the standard model cannot explain how these giant structures grew so fast, we are forced to ask a terrifying question. Could these massive anomalies actually be the remnants of a universe that existed before our own? Did these supermassive black holes somehow survive the death of a previous eon, carrying their mass across the boundary of time itself? If Penrose is right, then the little red dots and the universe breakers might not be newly born structures at all. They might be the glowing ancient ghosts of a previous cosmos, seeds that were planted long before the Big Bang ever happened. This possibility cracks the foundation of modern science wide open. We are no longer just arguing about the timeline of galaxy formation. We are arguing about the very definition of reality. Imagine you are a detective investigating a crime scene, and you find fingerprints belonging to a person who died 1 billion years before the crime took place. That is the exact level of impossibility that astronomers are currently facing. Every time they point the telescope at the dark ages, they find impossible giants that refuse to be explained by conventional physics. The rigid, comforting dogma of the lambda CDM model is collapsing under the weight of these impossible observations. What began as a minor discrepancy in the expansion rate has now evolved into an existential crisis for astrophysics. The universe is older, stranger, and far more complex than the simple, linear story we desperately wanted to believe. We are forced to confront the very real possibility that our universe is haunted by the corpses of previous worlds. In just a few moments, you will see exactly how a black hole can survive the end of time itself. To see exactly how a black hole can survive the end of time, we have to look inside the incredibly violent mechanics of a dying universe. To understand this properly, we first need to completely dismantle one of the most stubborn myths in popular science. Most people believe that black holes are immortal, cosmic vacuum cleaners that simply sit in the dark forever. You probably imagine them as eternal gravity wells slowly swallowing everything around them until the end of time. But they are not immortal. They are dying. This realization is where the anatomy of the cosmos becomes profoundly strange. The mechanics of this process are governed by what we call Hawking evaporation. According to quantum mechanics, empty space is not actually empty. It is constantly boiling with virtual particles. More particle and antiparticle pairs spontaneously pop into existence, borrowing energy from the vacuum, and then instantly annihilate each other, disappearing back into nothingness. This happens everywhere, all the time. But when this happens exactly at the edge of a black hole, right on the event horizon, the rules change. To fully grasp this, you have to understand that the event horizon is the absolute point of no return. Once anything crosses that invisible boundary, not even light can escape the crushing gravitational grip. So when that virtual particle pair separates, the one that falls in is lost forever. The one that remains outside, however, has no partner to annihilate with. It becomes a real particle, carrying positive energy away from the event horizon and escaping out into the wider universe. Because energy cannot be created from nothing, the escaping particle actually steals a microscopic fraction of the black hole's mass. Over unimaginable stretches of time, the black hole slowly leaks its mass away into the void as radiation. This is a phenomenally slow process for a supermassive black hole. But as the black hole loses mass, the evaporation accelerates. The smaller it gets, the hotter it burns. In its final moments, it does not just quietly fade out. It detonates with an absolutely colossal explosion, releasing all of its remaining energy in a blinding flash of high-energy radiation. So, think of a gigantic, towering glacier floating in the middle of a warm ocean. For thousands of years, you would barely notice it shrinking. It just slowly drips water, molecule by molecule, completely silent and seemingly permanent. But as it gets smaller and smaller, the melting speeds up. Now imagine that in its absolute final second, instead of quietly melting away, the remaining block of ice violently detonates like a thermal bomb, instantly vaporizing the surrounding ocean. That is the exact life cycle of a supermassive black hole. It spends trillions of years slowly dripping energy, only to end its existence in an apocalyptic burst of unimaginable violence. Now, we must apply this anatomical mechanism to the very end of the universe, a period Roger Penrose describes as the late stages of an eon. Imagine the cosmos a Google years from now. That is a 1 followed by 100 zeros. By this time, all the stars have long since burned out. The galaxies have disintegrated. The universe is a freezing, expanding void, populated only by wandering supermassive black holes. Eventually, over incomprehensible timescales, even these gravity monsters will undergo Hawking evaporation. One by one, they will shrink, burn hotter, and finally detonate in spectacular explosions of radiation. When the absolute last black hole in the universe finally explodes, something mathematically profound happens. This is where the core mechanics of conformal cyclic cosmology come into play. Once all the black holes are gone, the universe is left with absolutely no mass. It contains only massless particles, primarily photons of light, traveling through an infinitely expanding void. But according to Einstein's theory of relativity, if there is no mass, time effectively ceases to exist. Mass is what creates the ticking of a clock. Photons do not experience time. For a particle of light, the journey from one side of the universe to the other happens in 0 seconds. In a universe strictly filled with massless radiation, there is no physical way to measure distance or duration. The concepts of large and small completely lose their physical meaning. In physics, without mass to interact with, you cannot build a ruler. You cannot build a clock. The fundamental geometry of space itself becomes scale invariant, meaning that the mathematical equations that describe a vast, expanding void are exactly the same equations that describe a tiny, microscopic point. Imagine you're zooming in on a perfect fractal. No matter how far you zoom in, or how far you zoom out, the mathematical structure looks absolutely identical. When the universe reaches this ultimate state of empty, massless expansion, it literally forgets how big it is. Through a mathematical process known as conformal rescaling, Penrose proved something utterly breathtaking. A universe that is infinitely large, infinitely cold, and completely devoid of mass is mathematically identical to a universe that is infinitely small, infinitely hot, and completely devoid of mass. The end state of our dying cosmos is mathematically indistinguishable from the exact moment of a Big Bang. They are the exact same physical state. Therefore, the Big Bang was not a beginning out of nothingness. It was simply the conformal boundary where a dying, infinitely expanded universe seamlessly transitioned into the infinitely hot, dense birth of the next cycle. The end of the old eon is the exact same event as the beginning of the new one. The universe resets. Space and time are fundamentally recycled. But what about those final colossal explosions from the evaporating supermassive black holes? This energy does not just disappear when the universe resets. Penrose calculates that these massive bursts of radiation actually cross the conformal boundary. They bleed through into the next universe. Because the energy was concentrated in a specific location when the black hole exploded, it imprints a permanent physical scar onto the infant universe that follows. These scars appear as massive heated rings of concentrated energy in the cosmic microwave background. We call them Hawking points. If Penrose's anatomical model of the universe is correct, it completely rewrites the rules for how early galaxies could form. The standard model tells us that the early universe was a smooth, quiet soup of gas that took billions of years to slowly pull together into stars. In the standard model, the Dark Ages were characterized by a painfully slow accumulation of neutral hydrogen gas. Gravity had to start from absolute scratch, pulling microscopic ripples of matter together over hundreds of millions of years just to form a single, fragile star. But a Hawking point changes the entire physics of the early cosmos. Because these points contain the concentrated explosive energy of a dead supermassive black hole, they create massive gravitational wells right at the very dawn of time. The surrounding gas does not have to slowly drift together. It is violently yanked into these pre-existing wells. Instead of waiting hundreds of millions of years for tiny dwarf galaxies to merge, these inherited seeds would allow gigantic structures to collapse and ignite almost immediately. This perfectly explains the impossible nightmare discovered by the James Webb Space Telescope. The universe breakers, the little red dots. These massive, fully formed galaxies exist too early because they didn't start from scratch. They were seeded by the violent deaths of supermassive black holes from a universe that existed before time itself began. They inherited their colossal mass from the ghosts of a previous eternity. The closer you look at the beginning of our universe, the more you realize you're staring at the violent end of another. To understand what this violent end actually looks like, we first have to look at the mechanics of direct collapse. If the glowing embers of a previous universe really did bleed through the conformal boundary, they would have completely rewritten the rules of how the earliest galaxies formed. To see how these phantom seeds created the impossible little red dots, we have to examine exactly how supermassive black holes grow. And to do that, we must destroy another deeply ingrained misunderstanding about the cosmos. When you think of a black hole growing, you probably imagine a slow, methodical, cosmic vacuum cleaner. This is a widespread myth. Most people assume that supermassive black holes, the monsters sitting at the center of galaxies, grew to their gargantuan sizes by patiently swallowing one star at a time over billions of years. We are taught to visualize a slow drip of matter falling into a gravity well, steadily increasing its mass in a peaceful linear fashion. But the universe does not work like a simple vacuum cleaner, and the little red dots prove that this slow growth narrative is a mathematical impossibility. The reason a black hole cannot just eat everything around it instantly is governed by a strict physical law called the Eddington limit. When a black hole feeds on surrounding gas and dust, that material does not just fall straight in. it spirals around the event horizon, forming an accretion disk. As this material swirls closer and closer to the absolute edge, it accelerates to a significant fraction of the speed of light. The friction within this violently swirling disk is incomprehensible. The gas heats up to millions of degrees, transforming into a glowing hypercharged plasma. And when matter gets this hot, it emits a ferocious amount of radiation. To truly understand this violence, you must realize that gravity is not the only force at play near an event horizon. Electromagnetism becomes incredibly dominant when gas is stripped of its electrons. The magnetic fields twist and snap, launching towering jets of charged particles thousands of light years out into deep space. This chaotic environment acts like a cosmic furnace, converting the gravitational potential energy of the falling gas directly into pure blinding light. This radiation exerts a physical pressure outward, pushing against the very gas that is trying to fall in. The Eddington limit is the exact equilibrium point, where the outward pressure of the radiation perfectly balances the inward pull of gravity. If a black hole tries to feed too fast, the accretion disk becomes so incredibly hot and bright that the radiation literally blows the remaining food away. The black hole effectively starves itself by being too greedy. It is a fundamental cosmic speed limit, a physical governor that strictly dictates how fast a gravity well can accumulate mass. Imagine you're trying to build the largest bonfire in the world. You have a small burning flame, and you decide to feed it by dumping an entire massive dump truck full of sawdust directly onto it all at once. Instead of instantly creating a towering inferno, the sheer volume of the sawdust smothers the flame. The sudden, initial burst of heat from the trapped fire rapidly expands the air and violently blows the rest of the unburned sawdust away in a massive cloud. To make the fire grow to a gargantuan size, you have to feed it slowly, shoveling the fuel at a very specific controlled rate so that the heat does not blow the remaining fuel away. That is exactly how the Eddington limit restricts a black hole. It forces them to starve. This brings us to a massive screaming paradox. If the Eddington limit forces black holes to grow at a painstakingly slow pace, then the little red dots discovered by the James Webb Space Telescope should not exist. When Vadim Rusakov and Albert Sneppen looked at these objects, they calculated the mass of the black holes powering them. The numbers were absolutely terrifying. These black holes contain the mass of hundreds of millions of suns, yet they exist in a universe that is only 500 million years old. Even if these black holes started growing at the exact moment of the Big Bang, they would not have enough time. If they fed continuously at the maximum speed allowed by the Eddington limit without ever taking a break, they still could not get this big. The math is broken. The timeline is fundamentally violated. To solve this existential crisis, astrophysicists had to look for a completely different anatomical mechanism, a shortcut that bypasses the slow, starving accretion process entirely. They found it in a theoretical model known as the direct collapse black hole. In the modern universe, a black hole is born when a massive star runs out of fuel and its core collapses under its own weight. This creates a stellar mass black hole, which is relatively small, perhaps 10 to 50 times the mass of our Sun. But in the extremely early universe, things were vastly different. There were gargantuan, pristine clouds of pure hydrogen and helium gas stretching across thousands of light years. These primordial clouds were untainted by the heavy elements that exist today. In our modern universe, elements like carbon and oxygen act as coolants, radiating heat away and allowing the gas to gently fragment into millions of small, dense pockets that eventually ignite as stars. But the pristine hydrogen and helium of the early universe could not cool down efficiently. They were stubborn, retaining their heat and refusing to break apart into small, manageable stellar seeds. According to the direct collapse theory, under the right, incredibly rare conditions, these massive clouds did not fragment to form thousands of individual stars. Instead, the entire cloud, containing hundreds of thousands of solar masses of gas, collapsed all at once in a single, catastrophic implosion. This process skips the star phase entirely. There is no nuclear fusion. There is no supernova explosion. An absolutely colossal amount of gas simply falls directly into a singularity, instantly creating a monster that weighs 100,000 times more than our Sun right at the moment of its birth. This provides the massive seed needed to explain the little red dots. By starting out huge, these black holes do not need billions of years of slow feeding to reach their gargantuan sizes. They bypass the Eddington limit bottleneck completely. But there is a major problem with this elegant solution. For a direct collapse black hole to actually form, the massive gas cloud must be prevented from cooling down and fragmenting into smaller pieces. It requires an intense, constant source of external heat or radiation to keep the gas perfectly smooth as it collapses. In a normal, quiet, early universe, this external heat source simply does not exist. The clouds would naturally fragment, forming ordinary boring stars. This is exactly where Roger Penrose's Hawking points enter the anatomical picture with terrifying precision. If the previous universe ended with the colossal detonation of supermassive black holes, the resulting Hawking points would bleed through the conformal boundary into our cosmic dawn. These ancient scars would act as unimaginably powerful hotspots of concentrated energy. They would bathe the surrounding pristine gas clouds in exactly the kind of intense, relentless radiation required to prevent them from fragmenting into stars. The ghosts of the previous eon provided the exact impossible conditions necessary to trigger direct collapse. The supermassive black holes of our universe were directly seeded, heated, and forged by the dying screams of the black holes from a previous eternity. It is a breathtaking synthesis of two completely different physical crises. On one hand, we have the impossible James Webb data showing fully formed galaxies existing far too early. On the other hand, we have Roger Penrose's fiercely debated mathematical models predicting ancient scars of radiation from a dead universe. When you put them together, the paradox perfectly solves itself. The universe you live in is not a self-contained story. Its largest, most violent engines were built using blueprints left behind by a dead cosmos. And yet, these direct collapse monsters are not the strangest thing hiding in the dark. But the dark isn't just hiding massive black holes, it's hiding the impossible light they create. If the supermassive black holes at the centers of these galaxies represent the violent hidden engines of the early cosmos, then the stars surrounding them represent the impossible exhaust. The little red dots are not just defined by their staggering mass. They are defined by what they are made of. And to understand why their chemical composition is causing a meltdown in astrophysics, we must abandon yet another obsolete classification system that has clouded our judgment for decades. For a very long time, astronomers organized the evolution of the cosmos into a neat generational hierarchy. We were taught that stars evolved in strict sequential waves. The very first generation, known as Population 3 stars, were supposed to be massive, pure, and completely devoid of any heavy elements. They were built exclusively from the pristine hydrogen and helium forged in the Big Bang. According to the textbooks, you had to wait for these primitive giants to die before you could get the next generation, Population 2, which would contain a tiny trace of heavier materials. Our own Sun is a Population 1 star, rich in complex elements, standing at the very end of this long, slow evolutionary assembly line. This rigid step-by-step classification system dictated our expectations for the James Webb Space Telescope. When we pointed the most powerful machine ever built at the dawn of time, we were absolutely certain we would only find those pure, untouched Population 3 stars. But the data that came back completely shattered this generational myth. The mechanics of how the universe creates heavy elements is known as the nucleosynthesis cycle. A star is essentially a gigantic self-contained nuclear fusion reactor. Deep in its core, immense gravity crushes simple hydrogen atoms together to form helium. When the hydrogen runs out, the core gets hotter and crushes helium into carbon, then oxygen, silicon, and eventually iron. But a star cannot share these heavy elements with the rest of the universe while it is alive. it hoards them in its core. A star spends millions of years fighting a relentless war against its own gravity. Gravity wants to crush the star into a singularity, while the outward pressure of the nuclear fusion in the core pushes back, keeping the star stable. This delicate balance holds only as long as there is fuel to burn. But when a supermassive star finally exhausts its supply of heavy elements, the outward pressure vanishes in an instant. Gravity wins the ultimate battle. The entire mass of the star collapses inward at a significant fraction of the speed of light, bounces off the ultra-dense iron core and rebounds outward. To distribute these crucial building blocks of life, the massive star must reach the end of its life cycle, collapse, and detonate in a catastrophic supernova. The violent explosion shreds the star, scattering its heavy elements out into the cold void. Only then can a new cloud of gas collapse to form the next generation of stars, this time polluted with the heavy elements from the previous generation's ashes. Imagine you're observing an ancient factory that has just opened its doors for the very first time. Based on the blueprints, you expect the workers to start by building the most primitive, basic bicycles imaginable, using nothing but raw iron. You assume you will have to wait decades for them to slowly invent gears, chains, and complex alloys. But when you peer through the windows on day one, a fully assembled, hyper-advanced jet engine rolls off the assembly line. The evolutionary steps, the slow accumulation of knowledge and technology, have been completely bypassed. The factory is producing the end product at the very beginning of the timeline. This is exactly the nightmare scenario astronomers encountered when they analysed a galaxy named JWST 14. This specific galaxy is currently the most distant ancient structure ever confirmed by human eyes. The light we are seeing left that galaxy when the universe was less than 300 million years old. According to the strict rules of the Standard Model and the slow nucleosynthesis cycle, this galaxy should have been a pristine sanctuary of primitive hydrogen and helium. It should have been populated exclusively by the very first generation of stars. But when the James Webb Space Telescope analysed the chemical spectrum of this impossible giant, it found something that made the researchers gasp. The light signature was saturated with massive amounts of oxygen and carbon. Oxygen is not a light, primitive element. It is a complex, heavy atom that requires intense, prolonged nuclear fusion to create. Finding such a massive concentration of oxygen at a redshift of 14.32 is like finding a modern smartphone buried inside a Jurassic fossil. It is an anachronism that defies all logical explanation. Furthermore, the sheer brightness of this galaxy suggests it spans over 1,600 light-years across. This is an absolutely gargantuan footprint for an era when galaxies were supposed to be tiny, fragile clumps of gas no bigger than a few dozen light-years. The JWST 14 system is not an isolated freak occurrence. It is part of a growing catalogue of early massive structures that are systematically dismantling the lambda CDM model. This single chemical signature is a devastating blow to the Standard Model. For a galaxy to be flooded with oxygen that early in the timeline, multiple generations of massive stars must have already lived their entire lives, burned through their fuel, and exploded in spectacular supernovas. The nucleosynthesis cycle was not crawling. It was operating at a frantic, chaotic, and unimaginably fast pace. The universe was sprinting through stellar generations before it even had time to take its first breath. When we combine this with the direct collapse black holes from the previous block, the true anatomy of the cosmic dawn finally comes into terrifying focus. We are looking at a dual engine of impossibility. On one side, supermassive black holes are bypassing the Eddington limit by collapsing directly from pristine gas, seeded by the radioactive scars of a previous universe. On the other side, the surrounding stars are burning, dying, and recycling their heavy elements at a speed that physically breaks the standard chronological timeline. The early universe was not a quiet, dark void waiting for gravity to slowly do its work. It was a chaotic, hyper-efficient factory working in absolute overdrive, churning out mature galaxies and heavy elements almost instantly. The Standard Model of cosmology is completely unequipped to explain this ferocious level of activity. timeline we have relied on for decades is mathematically incompatible with the physical reality staring back at us through those golden mirrors. We have finally mapped the cosmic dawn only to realize that the map we drew is entirely fiction. But to understand how this chemical impossibility occurred, we have to travel back to the exact moment it happened. To see exactly how this exact moment unfolded, we have to look inside the darkest corner of the cosmic dawn. We have spent the last few minutes dismantling the old timeline, revealing direct collapse black holes and impossibly rapid star formation. But the true terror of the James Webb discoveries is not just about isolated anomalies. It is about how all of these impossible things are happening perfectly simultaneously, creating a physical knot that simply cannot be untied. We have now reached the absolute center of the labyrinth. This is the central paradox. At the very heart of this crisis are the little red dots and the JWST 14-0 galaxy. The scientific community could easily accept one minor anomaly. If we only found a black hole that was slightly too massive, theorists could tweak the Eddington limit equations. If we only found a trace amount of oxygen that was slightly too early, chemists could argue about the efficiency of early supernovas. But the universe did not give us minor anomalies. It gave us a massive, fully mature galaxy containing a gargantuan supermassive black hole, completely saturated with heavy elements like oxygen and carbon, all sitting together in the exact same location in space. And they are all existing at a time when the universe itself has barely even started. To fully appreciate this nightmare, you must understand the brutal math of the timeline. The accepted age of the universe is 13.8 billion years. These impossible structures exist when the universe is just under 300 million years old. That means they are fully formed when the cosmos is at barely 2% of its current age. If the entire 13.8 billion year history of the universe was compressed into a single human lifespan of 80 years, then 300 million years is equivalent to a baby that is barely 20 months old. Imagine walking into a nursery and finding a toddler who has somehow already lived a full life, earned multiple doctorate degrees, built a massive skyscraper, and is now sporting a long grey beard. It is not just unlikely. It is a fundamental violation of cause and effect. Skeptics immediately tried to find a way out of this trap. They argued that the distance measurements must be wrong. Perhaps these galaxies are actually much closer to us, and therefore much older, which would give them plenty of time to grow. But the James Webb Space Telescope eliminated that escape route using a phenomenon known as the Lyman alpha break. Neutral hydrogen gas, which filled the early universe like a thick fog, absorbs specific wavelengths of ultraviolet light. When the first stars ignited, their intense ultraviolet radiation attempted to pierce through this dense cosmic fog. But the neutral hydrogen atoms are incredibly greedy for specific energies of light. When a photon with a wavelength of exactly 121.6 nanometers hits a hydrogen atom, it is instantly absorbed. This creates a hard, undeniable cutoff in the spectrum of light, a sheer cliff face where all light at shorter wavelengths is completely wiped out by the fog. This cliff face is the Lyman alpha break. As the light from these distant galaxies travels through the expanding universe for billions of years, this absorption signature is stretched, or redshifted, deeper and deeper into the infrared spectrum. The James Webb instruments measured this Lyman alpha break with devastating, unforgiving precision. The signature for JWST 14-0 is undeniable. It is pinned at a redshift of 14.32. The data is not a glitch, the calibration is perfect, and the instruments are performing exactly as designed. The galaxy is definitely trapped in the deepest, darkest restricted zone of the cosmic dawn. So, we are left with a perfect, unbroken chain of logic that leads us directly into a concrete wall. The redshift data definitively proves the galaxy is existing when the universe is a mere infant. The spectroscopic data definitively proves the galaxy is heavily polluted with oxygen, which requires hundreds of millions of years of stellar death to produce. The luminosity data definitively proves the galaxy is powered by a supermassive black hole, which requires billions of years of slow feeding to grow. Every single piece of data is completely correct on its own, yet when you put them together, they contradict each other in a way that breaks physics. You cannot change one variable without completely destroying another fundamental pillar of science. If you argue that the redshift measurement is wrong, you have to throw away our entire understanding of quantum mechanics and light absorption. If you argue that the chemical data is wrong, you have to throw away nuclear physics and everything we know about how fusion works inside a star. If you argue that the black hole mass is wrong, you have to throw away gravity and the theory of relativity. It is an inescapable, perfectly constructed logical trap. Desperate for a solution, cosmologists tried to classify the ways a black hole could possibly grow fast enough to solve at least part of the paradox. They divided the theories into two categories: light seeds and heavy seeds. The light seed theory suggests that black holes start from the collapse cores of ordinary stars and slowly merge over time. As we have already seen, the Eddington limit makes this completely impossible. There is simply not enough time for light seeds to merge and grow. So they turn to the heavy seed theory, which is the direct collapse black hole model we explored earlier. In this model, gargantuan clouds of pristine gas collapse directly into massive singularities, completely bypassing the stellar phase. But this is where the knot pulls tight and suffocates the standard model completely. The heavy seed theory has a strict unbreakable rule. For a massive cloud of gas to collapse directly into a black hole without fragmenting into stars, the gas must be absolutely pristine. It must be pure hydrogen. If there is even a tiny trace of heavy elements like oxygen or carbon, those elements act as coolants. They radiate the heat away, causing the cloud to immediately shatter into millions of tiny pieces, forming normal stars instead of a giant black hole. The universe has cornered us in a dark alley. To build the supermassive black holes seen in the little red dots, you absolutely need an environment completely free of oxygen. But the James Webb data proves that the exact galaxies housing these black holes are already deeply polluted with massive amounts of oxygen. You need pristine gas to build the monster, but the monster is sitting in a galaxy that has already lost its purity. They physically cannot exist together. Yet, there they are, staring back at us from 13.5 billion light-years away, completely ignoring our rules. The timeline is not just cracked, it is shattered into dust. To escape this brutal logical trap, some theoretical physicists have started looking beyond the Big Bang entirely. They are turning to a class of theories known as bounce cosmologies. In a bounce cosmology, the universe does not begin from an infinitely dense singularity that suddenly explodes out of nothingness. Instead, a previous version of the universe collapses inward, contracting over billions of years until it reaches a state of maximum density. Just before it crushes itself into oblivion, quantum effects cause it to violently rebound, bouncing back outward in a massive expansion that we misinterpret as a Big Bang. If our universe is the result of a bounce, it provides a terrifying but elegant solution to the paradox. The supermassive black holes and the heavy oxygen didn't have to form in the first 300 million years of our current expansion. They were already there. They are the surviving wreckage of the universe that collapsed before ours began. They rode through the catastrophic bounce and emerged on the other side, fully formed and ancient right at the dawn of our time. But the discovery of this impossible contradiction raised an even more troubling puzzle. To understand what this troubling puzzle means, we first have to look at the fundamental nature of time itself. If the little red dots are actually the surviving wreckage of a previous universe, then our entire concept of a beginning is completely fractured. We have spent the last century believing that time began with the Big Bang. We thought it was a single, definitive moment when everything exploded out of nothingness. But if the cosmos is actually a continuous, eternal cycle of deaths and rebirths, then our timeline is fundamentally broken. And the most terrifying part is that we already have independent mathematical proof that our timeline is collapsing. It is a crisis tearing the physics community apart, and it is known as the Hubble Tension. To determine the exact age of the universe, astrophysicists have to measure how fast space is currently expanding. If you know how fast it is expanding today, you can mathematically hit the reverse button. You can then calculate exactly how long it took for everything to compress back into a single point. This expansion rate is called the Hubble constant. For decades, scientists have used two completely different, incredibly precise methods to measure this exact number. The first method looks at the cosmic microwave background, the ancient radiation left over from the very dawn of time. The Planck satellite spent years meticulously mapping the cosmic microwave background, capturing the afterglow of the Big Bang itself. They analysed the acoustic peaks in this primordial radiation. This is essentially listening to the sound waves frozen in the early plasma. From this, they created a standard model prediction for how fast the universe must be expanding today. It is an incredibly rigorous, mathematically beautiful derivation. By studying the tiny ripples in this ancient light, the Planck satellite calculated that the universe is expanding at roughly 67 kilometers per second per megaparsec. The second method looks at the local modern universe by measuring the light from pulsating stars and detonating supernovas in nearby galaxies. They use Cepheid variable stars which pulse with a predictable rhythm to measure the exact distance to nearby galaxies. They use Type Ia supernovas, massive exploding white dwarfs that burn with a standardized brightness, to measure distances even further out. This local measurement is direct, empirical, and brutally precise. When astronomers use this local method, they get a completely different number. They calculate the expansion rate at roughly 73 kilometers per second per megaparsec. For years, astronomers assumed that as their instruments became more accurate, these two numbers would eventually converge perfectly in the middle. But the exact opposite happened. As the James Webb Space Telescope and the Hubble Space Telescope gathered more precise data, the gap between the two numbers grew wider and more terrifying. It is now a 5 sigma discrepancy, which in physics means there is less than a 1 in a million chance that it is a simple statistical fluke. Imagine you hire 2 master architects to measure the exact length of a massive hallway. The first architect stands at the beginning of the hallway, uses a state-of-the-art laser measurement tool and definitively states the hallway is exactly 67 meters long. The second architect stands at the end of the hallway, uses a perfectly calibrated steel tape measure, and definitively states the hallway is exactly 73 meters long. The hallway has not changed. Both tools are functioning flawlessly. Both architects are mathematically flawless in their execution. Yet the numbers simply do not match. In astrophysics, this is not just a rounding error, it is an apocalyptic failure of the standard model. It means that something fundamental about the geometry of space and the flow of time is behaving in a way we do not understand. The Hubble tension tells us that the universe is expanding significantly faster today than it was in the past. If the expansion rate is accelerating in ways the standard model cannot predict, then the reverse calculation is totally compromised. We cannot confidently say the universe is 13.8 billion years old if we do not actually understand the physics of its expansion. The timeline is not a rigid ruler, it is a piece of warped, elastic rubber. And this brings the central paradox of the James Webb discoveries to an absolute horrifying climax. Let us look at the nightmare we have constructed. We have the little red dots, massive galaxies containing supermassive black holes that physically violate the Eddington limit, existing hundreds of millions of years before they should. We have the JWST 14 galaxy, completely saturated with heavy oxygen, requiring multiple generations of dead stars to exist in an era when the first stars had barely ignited. We have the direct collapse black holes, which require pristine hydrogen to form, yet they are sitting directly inside these oxygen-polluted environments. And finally, we have the Hubble tension, proving that the very fabric of expanding space is acting in defiance of our physical laws. Plus, the lambda CDM model, the standard theory that says the universe began from a smooth singularity and evolved slowly over billions of years, cannot explain a single one of these anomalies. Every single piece of new, high-precision data screams that the standard model is wrong. The lambda CDM model assumes that dark matter pulls galaxies together, while dark energy pushes them apart in a predictable, constant tug-of-war. But the little red dots completely ignore this carefully balanced equation. They suggest that the early universe was dominated by forces so violent and extreme that they fundamentally bypass the slow, gravitational assembly required by dark matter. And the Hubble tension proves that dark energy is not acting the way we expect it to. It might be changing over time, growing stronger and accelerating the expansion of space in a chaotic, unpredictable manner. We are trying to force these impossible puzzle pieces into a box that was designed 50 years ago, and the box is physically tearing apart at the seams. But what if these are not four separate, unrelated problems? What if the Hubble tension, the early oxygen, the impossible black holes, and the little red dots are all symptoms of the exact same underlying reality? To solve this, we must push the implications to the absolute extreme. We must confront the possibility that the Big Bang was not the beginning of time. Perhaps the universe never actually started. Perhaps it has always existed. If we accept the conformal cyclic cosmology proposed by Roger Penrose, or the bounce cosmologies championed by theoretical physicists, the entire paradox instantly dissolves. The central terrifying puzzle we opened with at the very beginning of this journey finally has a logical answer. We asked how the galaxies in the early universe grew so massively and so quickly. They didn't. The supermassive black holes did not break the Eddington limit to grow in 300 million years. The stars did not rush through the nucleosynthesis cycle in a fraction of a second. They didn't have to cheat time because they had an eternity to grow. They simply inherited their colossal mass, their heavy oxygen, and their gravitational dominance from a universe that came before ours. They didn't start from scratch because there is no such thing as scratch. The concept of a true beginning is an illusion. A moment of absolute zero where time and space burst from nothingness does not exist. It is an illusion born from the limitations of our own mathematics. When Roger Penrose looked at the equations of general relativity, he realized that a singularity is not a physical reality. It is a mathematical breakdown. The universe does not tolerate infinite density and infinite temperature. Instead of crushing down into a broken point, the cosmos finds a way to slide smoothly into the next phase. The massive growth we are seeing is not a miracle of the early cosmos. It is a ghost story from a previous eon. The Big Bang was simply a bottleneck, a cosmic reset button where an old, dying universe collapsed or transitioned into a new expansion phase. The little red dots are the survivors of that transition. They are the bruised, battered, but incredibly massive remnants of a previous eternity, bleeding through the conformal boundary into our cosmic dawn. When James Webb looks back into the deep infrared, it is not photographing the birth of our universe. It is conducting an archaeological dig in a cosmic graveyard. We live in a haunted house, built on the foundations of countless dead universes, each one leaving its radioactive scars and supermassive ghosts for the next cycle to inherit. Every time you look up at the night sky, you're not just seeing the current iteration of reality. You're looking through a window into the deep, infinite past. The glowing embers of dead galaxies, the concentrated scars of ancient black holes, and the heavy atoms of oxygen forged in long-forgotten supernovas are all floating silently in the dark, watching us. We are the cosmic latecomers, wandering through an ancient ruin that was already impossibly old before our timeline even started ticking. The universe is not a clean one-way street leading from nothingness to the present. It is an infinite loop of destruction and rebirth. In just a few moments, you will see exactly how we can physically prove this eternal cycle is real, light in existence. Some of these rings are so gargantuan that they appear larger than the full moon in our night sky, meaning they represent physical structures that are billions of light years across. If these rings are truly what Penrose claims they are, the philosophical and scientific implications are absolutely staggering. You're looking at the blast radius of a supermassive black hole that exploded before time itself even existed. These rings are physical objects made of pure energy that survive the death of an entire cosmos and erode through the Big Bang completely intact. They are the gravitational seeds that eventually pulled in the pristine gas of our early universe, triggering the direct collapse mechanism that forged the little red dots. The rings in the CMB are the blueprints, and the impossible James Webb galaxies are the finished buildings. The entire system connects flawlessly, bridging the terrifying gap between the deepest past and the deepest reaches of space. The little red dots are no longer an impossible paradox of speed and mass. They are simply the logical consequence of a universe that inherited its gravitational structure from a dead ancestor. The oxygen flooding the JWST 14-0 galaxy is not a timeline violation. It is the recycled ash of supernovas that burned and died trillions of years before our current concept of time even began. We are living in a second-hand cosmos, a recycled reality built entirely from the wreckage of a previous eternity. But to truly grasp the horror of this eternal cycle, we must shift our perspective from the macro scale of distance to the macro scale of time. How long does it actually take to create a Hawking point? How much time must pass in the dying universe for a supermassive black hole to fully evaporate and detonate? The mathematics of Hawking radiation are unforgiving. Consider a black hole the size of the monster at the center of the Milky Way. For it to slowly leak its mass away into the freezing void requires a length of time that defies human comprehension. Physicists estimate the complete evaporation of a supermassive black hole takes roughly 1 Google years. That's the number 1 followed by 100 zeros. 1 Google years. Let us try to force this number into a scale you can visualize. Imagine you are given an absolutely impossible punishing task. Your job is to take a single microscopic atom of hydrogen from the very edge of the observable universe and carry it across the entire 93 billion light-year diameter to the exact opposite edge. However, the rules dictate that you're only allowed to move this atom a distance of 1 single millimeter every 1 trillion years. You must slowly, painstakingly carry this atom across the entire cosmos, millimeter by millimeter, waiting 1 trillion years between each step. When you finally reach the other side, you must travel all the way back, pick up a second atom, and repeat the entire agonizing process. You must continue doing this until you have successfully relocated every single atom in the entire observable universe. The sheer monotony, the absolute agonizing slowness of moving an entire universe 1 millimeter every trillion years is enough to break the human mind. Yet the mathematics of the cosmos demands exactly this level of patience. Black holes do not rush. They are the ultimate perfect timekeepers of the dark era, slowly dripping their mass away into the freezing void, completely indifferent to the passing of eons. While you are moving your atoms, the black hole sits there, a silent, invisible monument to the end of all things. When you have finally finished this incomprehensible labor, when you have moved an entire cosmos atom by atom, the supermassive black hole has barely even noticed the passage of time. It has not even begun its final detonation sequence. That's the true scale of a Google years. It is a stretch of time so vast, so incredibly empty and dark, that the entire 13.8 billion year history of our current universe is less than a microscopic flash in the pan. Our Big Bang, the formation of our galaxies, the evolution of human life, and the eventual death of every star in our sky all happen in a flash. They are nothing but the absolute blink of an eye compared to the agonizing Google year wait for a black hole to finally die. Only after this incomprehensible eternity does the black hole detonate, creating the explosive burst of energy that will become a Hawking point in the next cycle. The universe expands, empties, forgets its own scale, and undergoes conformal rescaling. The boundary is crossed. A new Big Bang ignites and the cycle begins all over again, completely indifferent to the trillions of dead civilizations buried in the math. The cycle does not care about the civilizations that rise and fall on rocky planets. It does not care about the empires of light built by the galaxies. It only cares about the fundamental physics of expansion, evaporation, and the mathematical inevitability of the conformal reset. We are a fleeting, momentary spark in an engine that has been running forever, and it will continue to run long after our own sun has burned to a cinder and our own supermassive black holes have detonated to seed the next reality. So, the deeper you map the physical boundaries of our cosmos, the more you realize we're trapped in an eternal loop with absolutely no escape. But the search for this inescapable loop isn't just about theoretical math, it's about pushing the absolute limits of our physical engineering. We're not simply sitting in dark rooms, scribbling conformal rescaling equations on chalkboards and passively accepting our fate. Humanity has responded to this existential crisis by building the most sophisticated, hypersensitive eyes in the history of our species. We have launched a fleet of massive machines into the freezing void of space, specifically designed to hunt down the ghosts of the previous universe. The vanguard of this cosmic archaeological dig is the James Webb Space Telescope, and its primary weapon is a campaign known as the JWST program. JWST stands for the James Webb Space Telescope Advanced Deep Extragalactic Survey. This is not a mission designed to take pretty pictures of nearby nebulas. It is a ruthless, targeted operation aimed directly at the darkest, most impenetrable regions of the cosmic dawn. Using the near-infrared camera, or NIRCam, the JWST program stares unblinking into the deepest void for hundreds of hours at a time, patiently collecting photons that have been travelling since the universe was a mere infant. The near-infrared camera is not just taking a standard photograph. It is performing a surgical dissection of the light. Because the universe is expanding, the light from these ancient galaxies has been stretched over billions of years, shifting from visible blue light all the way down into the deep invisible infrared. NIRCam uses a series of highly specialized filters to capture this ancient stretched light across multiple different wavelengths simultaneously. By analyzing exactly how bright a galaxy appears in one filter compared to another, astronomers can perform a technique called photometric redshift estimation. This is how they pinpointed the exact age and distance of the little red dots with such terrifying speed and accuracy. They didn't have to wait years for spectroscopic follow-ups. The raw power of the JWST program handed them the impossible timeline almost immediately. It is this exact program that dragged the little red dots out of the darkness and forced us to confront the terrifying reality of their impossible mass and advanced chemical composition. But James Webb is not fighting this war alone. To truly understand the monsters lurking at the beginning of time, astronomers must combine the infrared data from space with terrestrial observatories here on Earth. High in the Atacama Desert in Chile sits the ALMA array, the Atacama Large Millimeter Submillimeter Array. While James Webb excels at seeing the blazing light of ancient stars and glowing supermassive black holes, ALMA is perfectly tuned to see what is hidden in the dark. ALMA detects the faint millimeter wavelength radiation emitted by cold cosmic dust and dense clouds of neutral gas. When Vadim Rusakov and Albert Sneppen from the University of Copenhagen began their groundbreaking analysis of the early galaxies, they did not just look at one dataset. They merged the ferocious infrared vision of James Webb with the cold, calculating radar of ALMA. The Copenhagen team realized that you cannot build a supermassive black hole without an absolutely colossal reservoir of cold gas to feed it. And you cannot build billions of mature stars without massive clouds of dust to serve as the stellar nurseries. Standard physics dictates that gathering this much cold dust and gas in one place and then slowly feeding it into a gravity well is a tedious, drawn-out process that requires billions of years of gentle gravitational nudging. But ALMA proved the dust was already there, perfectly organized and incredibly dense, sitting right next to the roaring black hole discovered by Webb. The two instruments, working perfectly in tandem, eliminated any possibility of observational error. The timeline was broken, and the machines proved it from two completely different angles. Imagine you are trying to understand a terrifying, chaotic symphony being played in absolute darkness. If you only use James Webb, it is like you're only allowed to hear the high-pitched screaming notes of the violins. You know something intense is happening, but you do not understand the rhythm. If you only use ALMA, it is like you can only hear the deep rhythmic booming impacts of the bass drums. You feel the power, but you miss the melody. But when Rusakov and Sneppen combined the two, the lights turned on, and the full, horrifying symphony was revealed. ALMA measured the immense amount of dust and gas required to fuel a massive galaxy, while James Webb measured the blinding light of the fully mature stars in the central black hole. By looking at both the fuel and the fire simultaneously, they mathematically proved that a process that should have taken 1.5 billion years had somehow completed itself in a fraction of that time. But the little red dots are only one half of the apocalyptic puzzle we constructed earlier. The other half is the Hubble Tension, the terrifying realization that the expansion of space is accelerating in a way that breaks our timeline. To solve this, humanity is preparing to deploy two new heavyweights into the cosmic arena. The first is the European Space Agency's Euclid telescope, which has already begun its dark mission. Euclid was not built to look at single distant galaxies like JDs. It was built to map the void itself. Euclid is currently constructing the largest, most accurate three-dimensional map of the universe ever attempted. It will observe billions of galaxies across more than a third of the entire sky, creating an unprecedented catalogue of cosmic geometry. To accomplish this impossible mapping task, Euclid utilizes a visible wavelength camera and a near-infrared spectrometer, sweeping across the cosmos in massive wide-angle arcs. It is looking for a subtle effect called weak gravitational lensing. As light from incredibly distant background galaxies travels toward Earth, it passes through the invisible web of dark matter that holds the universe together. The gravity of this dark matter bends and distorts the light, slightly altering the shape of the background galaxies when we finally see them. By measuring the microscopic distortions in billions of different galaxies, Euclid can literally see the invisible. It maps the exact distribution of dark matter across cosmic time, allowing scientists to see exactly how dark energy has been stretching the fabric of space. The true purpose of this massive 3D map is to hunt for the fingerprints of dark energy and dark matter. By precisely measuring how the shape and distribution of galaxies change over 10 billion years of cosmic history, Euclid will show us exactly how space has stretched over time. If the Hubble tension is real, if the universe is truly tearing itself apart in unpredictable ways, Euclid's map will expose the exact moment in history when the physics broke down. It will tell us if the expansion of the universe is a smooth, continuous line, or if it is a chaotic, warped curve that bends under the hidden influence of a previous eon. But the ultimate weapon in this observational arsenal is still waiting to be unleashed. In the late 2020 seconds, NASA will launch the Nancy Grace Roman Space Telescope. If James Webb is a sniper rifle, staring deeply and narrowly into the cosmic dawn, the Roman telescope is a wide-angle floodlight. It possesses the exact same ferocious optical power and resolution as the legendary Hubble Space Telescope, but with a field of view that is 100 times larger. In a single pointing, Roman can capture a massive panorama of the universe that would take Hubble hundreds of individual exposures to match. This panoramic power is specifically designed to hunt for the elusive wide-scale anomalies that James Webb might miss because its field of view is too narrow. One of the greatest challenges in cosmology today is that our view of the early universe is incredibly fragmented. We have deep, highly detailed images from Webb, but they only cover an area of the sky equivalent to the size of a pinhead held at arm's length. To truly understand if the entire universe is governed by the conformal cyclic cosmology model, we need to know if the anomalies are everywhere, or just localized flukes. Roman will stitch them together. It will provide the ultimate, indisputable statistical sample. If it points its massive floodlight into the dark and finds millions of little red dots scattered across every single quadrant of the sky, the debate will be over. The Roman telescope will conduct massive surveys of the infrared sky, hunting for thousands of new little red dots and measuring the ancient radiation signatures that might confirm the existence of Hawking points. By capturing enormous swaths of the cosmos in absolute pristine detail, It will search for the giant concentric rings in the cosmic microwave background with a level of precision that the older Planck satellite could never achieve. The Roman telescope is our best chance to definitively prove that Roger Penrose's conformal cyclic cosmology is not just a mathematical theory, but the literal physical reality of the universe. We are no longer blind. The dark ages of cosmology, where we had to rely on theoretical guesses and blurry pixelated images from ground-based telescopes, are over. With the combined terrifying power of the JWST program, ALMA, Euclid, and the upcoming Roman telescope, we are mapping the conformal boundary of the Big Bang itself. We are stripping away the white noise of creation to look for the physical scars left behind by a dead eternity. These machines are working perfectly. They are showing us the absolute truth of our cosmic origins, pixel by agonizing pixel. And yet, the machines we built to find the truth might end up proving something much darker. To understand what this darker truth means for humanity, we have to look at the questions these machines are actually forcing us to answer. For decades, astrophysicists operated under a relatively comfortable illusion. We believed that if we could just build a telescope powerful enough, we could look back in time and witness the exact, definitive moment of creation. We thought we could photograph the literal birth of the universe. But the James Webb Space Telescope did not find a beginning. It found a fully operational, impossibly mature cosmic landscape. This brings us to the terrifying question we asked at the very start of this investigation. Are the impossible galaxies discovered by James Webb, the heavy, oxygen-rich, ultra-compact little red dots, actually the glowing remnants of a completely different universe that existed before our time began? Based on the suffocating weight of the evidence we have just explored, the Hubble tension, the broken timeline, the direct collapse black holes, and the Hawking points discovered in the cosmic microwave background, the answer appears to be yes. They are not the first galaxies of our universe. They are the last survivors of the universe that came before us. They rode out the apocalyptic conformal reset, carrying the heavy elements and the gravitational ghosts of a dead eternity directly into our cosmic dawn. If they truly are survivors from a previous cycle, then every textbook on modern cosmology is not just slightly inaccurate, it is fundamentally obsolete. We have been trying to read a book by starting at Chapter 2, completely unaware that Chapter 1 was written in a language we have only just begun to decipher. But accepting this horrifying reality only opens the door to even more impossible questions. If the little red dots are survivors, then their internal anatomy completely shatters our understanding of how cosmic structures are actually built. In the standard model of astrophysics, we believe there is a strict evolutionary sequence. First, you have a massive cloud of gas. Second, that gas collapses to form billions of stars, creating a galaxy. Third, over billions of years, the stars in the center of that galaxy merge, die, and collapse to form a supermassive black hole. The galaxy is the mother, and the black hole is the child. But the little red dots discovered by the JWST program show the exact opposite. The black holes inside these galaxies are far too massive for the tiny, compact clusters of stars surrounding them. The child is somehow larger and older than the mother. Imagine you're studying the ruins of an ancient, sprawling kingdom. Logic tells you that a civilization must first build a massive city, establish a strong economy, gather resources, and then, eventually, construct a towering, heavily fortified castle in the center for their king. But when you dig up the little red dots, you find something completely backwards. You find an impossibly massive, fully constructed castle sitting alone in the wilderness, surrounded by just a handful of hastily built wooden huts. The king did not wait for the city to be built. The king was already there, radiating absolute power, and the meager city was simply dragged into existence by his overwhelming gravitational presence. This is the chicken or egg paradox of the early cosmos. Did the galaxy feed the black hole, or did the black hole forge the galaxy? The direct collapse mechanism we discussed earlier suggests the black hole was born instantly from a gargantuan cloud of pristine hydrogen, bypassing the need for a host galaxy entirely, It established absolute gravitational dominance in the void before the first stars even had a chance to ignite. This is a terrifying thought. And this paradox immediately bleeds into the ultimate mystery, the true nature of dark matter. If the supermassive black holes in the little red dots are actually the remnants of a previous eon, what does that mean for the invisible web of dark matter that supposedly holds them together? The lambda CDM model assumes that dark matter is a fundamental exotic particle native to our current universe. But if the Hubble tension is real, and the expansion of space is not behaving the way dark matter dictates it should, we must ask a far more disturbing question. Is dark matter actually a particle at all? Or is it simply the gravitational echo, the leftover spatial distortion of the dead galaxies from the previous cycle? Are we measuring the phantom weight of a trillion dead stars? Well, if dark matter is just the gravitational scarring of a previous eon, then our multi-billion-dollar particle accelerators are searching for something that simply does not exist. We are trying to trap a ghost in a jar. We are looking for physical particles to explain a phenomenon that is actually a geometric flaw in the fabric of space-time itself. We are rapidly approaching a philosophical dead end in our astrophysics. We are desperately trying to force the chaotic, recycled reality of the little red dots into a clean, mathematical box that requires a definitive beginning. But every new image from the James Webb Space Telescope, every new millimeter wave reading from ALMA, and every new geometric map from Euclid tells us the exact same thing. The box is broken. The universe does not owe us a neat, easily understandable origin story. But the answer to these questions will fundamentally change how we perceive our own place in the dark. You and I are standing on the precipice of a terrifying new era in human understanding. For thousands of years, we have comforted ourselves with the idea that the universe is a linear story. We believed it had a definitive beginning, a steady progression of time, and a final, permanent ending. But the data flooding in from the deepest reaches of the cosmos is systematically destroying that narrative. The James Webb Space Telescope has looked into the abyss and found something far older and far more disturbing than a simple Big Bang. It has found a universe that refuses to die. Thousands of years ago, ancient civilizations across the world independently created the exact same mythological symbol, the Ouroboros. It is the image of a massive serpent violently devouring its own tail. For our ancestors, it represented the infinite, inescapable cycle of destruction and rebirth, the idea that the end of one world is the exact biological fuel required to birth the next. They did not have infrared space telescopes. They did not have supercomputers to calculate the evaporation rate of supermassive black holes. They only had intuition. But today, modern astrophysics is proving that the Ouroboros is not just a philosophical metaphor, it is the literal physical blueprint of reality. The dying universe is the tail, and the new universe is the mouth. The little red dots, the heavy oxygen flooding the cosmic dawn, and the colossal rings of energy scarred into the microwave background are the ultimate expressions of this cycle. They are the physical proof that the most fundamental law of thermodynamics, that nothing is ever truly created or destroyed, only transformed, applies not just to the atoms in our bodies, but to the fabric of space-time itself. The colossal black holes that dominate the early cosmos did not cheat time. They simply survived it. Or, the energy they amassed over a googol years of silent feeding was never lost. It was merely repackaged and violently injected into the new cosmic expansion. The universe is the ultimate inescapable recycling machine. They are the recycled ash of a dead eternity, carrying the gravitational memory of a previous eon across the conformal boundary and into our reality. When you finally grasp this realization, it forces a profound, almost paralyzing shift in how you view your own existence. We are not the pinnacle of creation, sitting proudly at the end of a long linear timeline. We are merely the temporary inhabitants of a haunted cosmos. Long before our Big Bang ever ignited, there were likely trillions of civilizations rising and falling in the dark, looking up at their own version of the night sky, completely unaware that their universe was slowly bleeding out. And long after our own sun has died, Long after our galaxies have evaporated into the freezing void, our own supermassive black holes will eventually detonate. We will become the Hawking points of the next cycle. We will be the ghosts haunting the next cosmic dawn. The universe does not care about our need for a neat, understandable origin story. It operates on a scale of time and violence that is utterly indifferent to human logic. It demands the destruction of everything to fuel the creation of anything. The cycle of the Ouroboros is absolute. The cosmos expands, it empties, and it dies, only to be crushed down and reborn from its own radioactive ashes. There is no beginning. The next time you look up at the stars, remember that there is no true end. There is only the eternal blinding light of the reset and the terrifying beautiful dark that follows. If this journey into the dark origins of our cosmos shifted your perspective, hit the like button and subscribe to the channel. We explore the most terrifying mysteries of astrophysics every single week. Tell us in the comments below, do you believe our universe is a recycled reality? In our next investigation, we are going to confront an even more disturbing question. We know the cosmos is unimaginably massive, but how do we actually know where the universe ends? What exactly is waiting for us at the absolute physical edge of reality, and what happens if you try to cross it? Turn on the notification bell so you don't miss it. Until next time, stay curious and keep looking up.